this direct approach. In this direct approach, firstly we are going to discuss about epoxide-based polymers. What do you mean by epoxide? Epoxide is a structure made up of carbon and oxygen linked between the ring. Like here you can see there is a catalytic copolymeration of epoxides and carbon dioxide. This is the reaction. These are the reagents. Like reactants are catalytic copolymeration of epoxides and carbon dioxide are the reactants. And we will be forming ring opening reactions. The ring opening reactions are basically of two types. One is strictly alternating polycarbonates, other one is polyether carbonates. In strictly alternating polycarbonates, we will form the molecular weights of like heavy molecular weights of products are formed with some well-defined metal complexes. And in polyether carbonates, we use double metal cyanides, generally called as DMC catalyst. And here also wide variety of molecular weights are formed, and it has huge applications and wide variety of properties also. So as I was saying, this is the reaction in which you have like that is the epoxide reacting with the carbon dioxide will give the two reactions. Alternating polycarbonate and second one is polyether carbonate. In alternating polycarbonate you can see that there is an alternating group structure, and in the polyether carbonate you can see the polyether group there. And reactions like so these are the reactants like oxydates, azidorates, vinyl ethers and diesteres. Then coming to catalyst, what do you mean by catalyst? A catalyst is a substance or a compound which is present in a reaction, which actually doesn't involve in a reaction, which generally improves or enhances the rate of the reaction. That is meant by catalyst. Here there are two types of catalyst. One is homogeneous catalyst and other one is heterogeneous catalyst. Homogeneous catalysts are generally represented by cobalt and it is surrounded by silent ligands with chromium. Here the tube is called as copper anion, that is chromium anions. Generally this is a complex structure. The other one is heterogeneous catalyst, that is formed with the zinc butyrate and double metal cyanide DMCs we call it. These are the DMCs and that is formed by the complex zinc butyrate as you can see in the picture. And we also have some special properties based on the superior thermal properties. That is, there is a special property for especially this polypropylene carbonate has a low glass transition temperature, that is Tg is equal to 37 degrees Celsius, and it has some limits. Like to improve this, we have like binary and bifunctional silane catalysts which are formed with indium oxide and carbon dioxide, which will produce polyethylene carbonate PIC, which has increased Tg, that is low glass transition temperature up to 108 degrees Celsius. And one more thing is we have special property as amphiphilic polycarbonates in carbon dioxide based polymers. This is the important property you can say, amphiphilic polycarbonate. What do you mean by amphiphilic? Amphiphilic is a special property in which we have a combination of two properties, that is homophilic and hydrophilic and hydrophobic. Hydrophilic is polar in nature, hydrophobic is non-polar in nature. So combination of those two is amphiphilic we call it. It has a versatile properties, especially it is used for many applications such as biological imaging and some battery applications also. In the next slide we are going to discuss about that battery. So here in this we can see as biological imaging is done by this amphiphilic polycarbonates only. There is a case here, actually there is a mice. The mice is suffering with a tumor. You can see the picture one. This is the picture one. Initially the tumor was like that. It is so heavy. So it is treated with the drugs. The drugs are the PDX passage and platinum and PDX polymethyl carbonate PGC we call it. So these two drugs we are using and they are curing the tumor. As you can see, after 3 weeks it will be cured and formed into this. And this is the ambient light, that is the UV light you can see in the pictures. It is very applicable in this type of imaging. Next, as I have already said in the previous slide, it is also applicable in fabrication of this LED. Application of this pure white LED is done with the help of this copolymerization, and this luminescent materials can be formed from this CPDs, carbonized polymer rods we say. As you can see, there is a 5-member cyclic carbonate, 5CC we call that. And here you can see the reactions. these are the step-by-step reactions involving. Finally, you get the blue color copolymer change, and that is reacted with this phosphorus. You get this kind of LEDs. Depends on this nanometer technology. After increasing or decreasing, you change the color of the LEDs. So actually, there is a detailed explanation for this. I will tell you the brief. What happens here is, we want a wide LED mix. We generally combine RGB, that is red, green and blue. We mix in the ratio of 3:6:1. But that is a complex and expensive procedure. To minimize that and to have a better enhancement in that, we use this phosphorus. The yellow yttrium phosphorus powder reacted with this blue color reactant formed here, carbon, and that is obtained as your white color LED. So this is the betterment of this usage of this 5-membered cyclic carbon.